So let's talk about second order differential equation that is a non-homogeneous type. Basically, second order non-homogeneous differential equation. So how would you know if your second order DE or differential equation is a non-homogeneous? It's simple. There is no zero on your right side. Rather, it is a given function. Okay? So basically, we have a function here, f of x, and it is not equal to zero. Otherwise, it would be just a homogeneous. Okay? But if it's, uh, you know, not zero, then it is just non-homogeneous. Okay? So before you proceed to this video, I recommend you to watch the video that I just made, which is second order differential equation. Wait, no. Second order homogeneous differential equation. Okay? Second order homogeneous differential equation. Why? Because after you've watched that video, especially the procedures that I taught in that video, you're going to use that in getting the solution for your second order non-homogeneous differential equation. Okay, so if you have not watched it, then I recommend you to watch that video first. Okay, second order homogeneous DE or differential equation. Okay, before you proceed to this video. Okay, so if you have watched it, then congrats. We can now proceed. All right. So let's proceed. So since we have a second order non-homogeneous differential equation, then we're going to use this as our general solution. Okay. We're going to use this as our general, oops, that's actually a good handwriting. Wait, general solution. There you go. General solution. Okay, we have u and v. Your u is a complementary integral function, and your v is we have particular integral function. Okay, so remember that I just said that your f of x, it could be anything. Okay, it could be a constant, it could be a polynomial, it could be a exponential, so on and so forth, right? So because there are many possibilities of your function f of x could be, therefore, we're going to discuss them one by one because each of the given function f of x, they have their own different methods for your particular integral function. Okay, so let's first discuss the easy one. Okay, what if your f of x is a constant function? What sorry, what if your f of x is just a constant? What are you going to do? Okay, so that's the thing that we're going to talk about. All right, so for your u, right, your u, it's mentioned that this is your complementary integral function, right? So basically, guys, you're going to get your u by applying what you have learned in your second order homogeneous differential equation. So the steps or procedures that I taught you guys on getting the general solution for your second order homogeneous differential equation, that's the same thing on how would you get your u. Okay? That's the same thing on how would you get your complementary integral function. On the other hand, your v, it depends. Okay, it depends of your f of x or your function. Okay, it depends on your f of x. Okay, it depends. So since we have a constant, and that's our topic for today, your function is a constant. Okay, therefore, actually, it is already mentioned here. Your f of x is equal to constant. So since your f of x is a constant, meaning it is just a number, therefore, there are conditions that you're going to use. So we have this one. Conditions. First condition, if your u or your complementary integral function does not contain a constant term, like does not contain a constant term, therefore, you're going to substitute v as your k, or basically v is equal to k. All right? Otherwise, on your second condition, if your u does contain a constant term, then you're going to substitute your v as your kx. Okay, your k is a constant. It is not a variable. It is a constant. So why do we need to use this k? Because you're going to find that value of your k later on. So what are the steps? Like how can you, basically get the solution? So without further ado, let's begin. Okay, remember these conditions. Okay, don't forget this one. Don't forget these two conditions. If your function is a constant. Okay, so for your first example, we have d squared y all over dx squared plus 5dy all over dx plus 6y is equal to 3. Now take a look. We have a constant term of 3. So therefore, you're going to apply these two conditions. Okay? And it is obviously not equal to 0, so it is a non-homogeneous differential equation. So remember, what is the general solution for a non-homogeneous second-order differential equation? It is y is equal to u plus v. Okay? Remember this one. Okay? So, let's do it one by one. Let's start with the easy one. Okay? Let's find your u. Okay? Let's find your u. So the way how you're going to find your u is the same way how you basically find a general solution for your second order homogeneous differential equation. Okay? So first, you're going to substitute, if you're going to recall the previous video about second order homogeneous differential equation, you're going to substitute your d for your d all over dx. So we will have, so we will have d squared times y plus 5, um, wait, 5 dy plus 6y is equal to 3. Then after that, you're going to factor the y in this expression. So we will have quantity d squared plus 5b, okay, plus 6 times y is equal to 3. That's it. Okay? So this is what you call, if you're going to recall, this is what you call the D operator form. Okay? Now, what you're going to do is you're going to substitute your D as your M. Okay? Substitute D as your M. Okay? And equate this expression to 0. Okay? So we will have M squared plus 5m plus 6 is equal to 0. And if you're going to recall this one, this is an auxiliary equation. Okay, this is an auxiliary equation. So let's now find the values for your m. So in here, you can use methods of factoring or use quadratic formula. Okay, for safety, and you don't want to be in hassle, and you want to be sure if they're both correct or not, use quadratic formula. But if you're confident enough that you know how to factor, then just factor. That's it. So for me, I'm going to factor this out because the factor of your m squared plus 5m plus 6 is quantity m plus 3 times quantity m plus 2. Since we have two m's and they are both different, okay, you know what? Let's find the m values first, okay, so that we can avoid confusion. So your m plus 3 is equal to 0. Transpose it to the right, we will have m is equal to negative 3. Then on the other hand, we have m plus 2, hold on, m plus 2 is equal to 0. Transpose it to the right side, we will have m is equal to negative 2. And as you can see, both of your m values are different to each other. And if they are different to each other, what are you going to do? Okay? If they are both different to each other, then, okay, your general solution for your u is a times e raised to small ax plus b times e raised to small bx. Okay, if you don't understand what I mean, then I suggest you should go back, watch the video that I made about second order homogeneous differential equation. Okay, but if you understand what I mean, then we're good to go. So yeah, because we have two different m values, so you are going to use this as your general solution for your u. Okay, so that's it. Now, pick which one is your A and which one is your B. So for me, this is my A, and this one will be my B. So we will have U as A times E raised to negative 3x plus B times E raised to negative 2x. So that is my U. Now, let's find your B. Okay, let's find your B. I'm going to use different color. So I'm going to use dark gray. Okay. How will you find your B? Okay. Now, take a look at your U. You have A times E raised to negative 3x plus B times E raised to negative 2x. Now, let's go back to the conditions. So yes, we have a constant for your function f of x. Now, let's go to your condition. If your U does not contain a constant term, your V is equal to K. Okay? If your U does contain a constant term, then your V is equal to Kx. Now let's go back here. Take a look. Look at this one. Is there a constant term? The answer is no. Okay? There is no constant term. So if there is no constant term, then your V is equal to your K. All right? So how would you know if it is a constant term? Simple. If basically there is a constant term here, like it could be a number, it could be a arbitrary constant, as long as it is a term, constant term, okay? Then your V is equal to K. Your V is equal to Kx. But if there's no constant term, just like this one, you have A times e raised to negative 3x, B times e raised to negative 2x, then your B is equal to K because there is no constant term. Okay? Your A and your B, these are just coefficients for your exponential functions. So they are not constant terms. All right? Okay? I'm just actually explaining it a lot so that you guys can get what I mean here. All right? Good. Now your B is equal to K. What are you going to do next? So first, copy your D operator form. Okay, copy this one. Okay, so we have this. Now that you have your D operator form, which is your D squared plus 5D plus 6 times Y is equal to 3, right? What you're going to do is you're going to substitute your V as your Y. So we will have D squared plus 5D plus 6 times your V is equal to 3. And since your V, wait, there we go. Since your V is equal to your K, therefore, you're going to what? Substitute your v as your k. So we will have d squared plus 5b plus 6 times k is equal to 3. Now what you're going to do is to distribute k to this expression. So we will have d squared k plus, wait, let me remove the parentheses. Wait, forgive me. Okay. So we will have d squared k plus 5dk plus 6k is equal to 3. Remember guys, that d is equal to d all over dx, right? So meaning d squared is d squared all over dx squared k plus 5 times d all over dx of k, hold on, of k plus 6k is equal to 3. So if your k is at your d, you're going to differentiate them. Get the derivative of your k. Okay, guys? Get the derivative of your k. Since you distribute your k to your d and your d squared, so you're going to get the derivative of them. Okay? So first, we have d squared all over dx squared of k. So meaning, the second derivative of your k. And remember, your k is a constant. Your k is a constant. So therefore, if you're going to get the second derivative of your k, this is just 0 plus 5 times the derivative of your k. Okay, again, it is a constant. So you're going to get 0 plus 6k is equal to 3. So obviously, 0 plus 5 times 0 is 0 plus 6k is equal to 3. Now, add them together, we will have 6k on your left side and on the right side, just 3. And now we're going to divide both sides by 6. And your k is equal to 1 half. So since your k is equal to 1 half, therefore your v is equal to 1 half. So what would be your final answer? Your final answer, okay, if you're going to rewrite here, we have y is equal to u plus v. So we will have y is equal to, your u is a times e raised to negative 3x plus b times e raised to negative 2x plus your v is 1 half. So we will have 1 half. So that is your general solution. Okay, this is your general solution. There you go. See, that's it. Now let's have one more example and we're done. Let's just say we have this one. 3d squared minus 6dy. Wait, sorry. 3d squared y all over dx squared minus 6dy is equal to 4. So how are we going to do this one? The same thing, okay? So again, we're going to find y is equal to u plus v as usual. Now, as always, start with your v, okay? Let's find your v, okay? Wait, no, sorry. Let's find your u. Forgive me, it's supposed to be u, all right? So, as usual, substitute your d all over dx as your capital D. So we will have 3d squared minus, forgive me, 3d squared y minus 6dy is equal to 4. All right? Then, wait. Then after that, you're going to factor out your y here. So we will have quantity 3d squared minus 6b, sorry, times y is equal to 4. So this is your d operator form. Now what you're going to do is to substitute your d as your m and equate this one to 0. So we will have 3m squared minus 6m is equal to 0. So now, let's get your values of your m. This one, I can actually factor it out. Okay? You can use quadratic formula if you like to, but for me, no need. I will just factor it out. So if you're going to factor it out, we will have 3m times quantity m minus 2. Okay, this is the factored form of this quadratic equation. Okay, because these two terms, 3m squared and negative 6m, are both divisible by 3. So your GCF is 3m, basically. So factor them both, we will have 3m times quantity m minus 2. So let's find your m values. So your m here, 3m is equal to 0. So divide both sides by 3. We will have m as 0. And here we have m minus 2 equated to 0. Transpose negative 2 to the right will make it into positive 2. So we have m is equal to 2. So due to this, what would be the general solution? Since we have both m's, okay, m values, and are different to each other, then you're going to use this general solution. So your u is equal to a times e raised to small ax plus b, plus b times e raised to small bx. Now let's take a look. Okay, you can now you can now substitute this one as your a and this one as your b, a small b. Okay, so for me, my 0 is my small a and my b is my small b is my 2. So again, it's up to you whether you like your a is your 2 and your b is your 0, or your small a is 0 and your small b is 2. So it's up to you. So since I made a as my 0, so we will have u is equal to a times e raised to 0 times x plus b times e raised to 2 times x. So since here we have 0 times x, we will have a e raised to 0 plus b e raised to 2x. Okay? And again, anything raised to 0 or has an exponent of 0 is equal to 1. So we will have u is equal to a times 1 plus b times e raised to 2x. So we will have your u as a plus b times e raised to 2x. So that is my u. So now that that is your u, we can now find your v. But before that, let me draw a border. Okay. Let me draw a border. That's it. Oh, wait. Now let's go. What would be your v? Now let's take a look. Right, we have a plus b e raised to raised to 2x. Again, go back to your conditions. If your u does not contain a constant term, then your v is equal to k. But if your u does contain a constant term, then your v is equal to kx. So as you can see, there is a constant term of a. It is not, sorry, this a is no longer a coefficient of an exponent, right? Rather, it is just a constant term, okay? Because a and b here are both arbitrary constants. But as you can see, A acts as a constant term, meaning it is just a constant term. It doesn't exist as a coefficient or as a partner of the other function, but as a constant term only. Therefore, your V is equal to Kx. And now let's find your Kx. So what to do? Get your D operator form. Okay, let's substitute it here. We're going to put it here. That's it. And then after that, you're going to substitute your V for your Y. So we will have 3D squared minus 6D times V is equal to 4. Okay. Now, since your V is equal to Kx, so we will have 3D squared minus 6D times Kx is equal to 4. Now distributed, we will have 3D squared Kx minus 6D Kx is equal to 4. Now, remember that your capital D is equal to D all over dx. So we will have 3 times D squared all over dx squared. Wait, let me fix that. D squared all over dx squared of Kx minus 6 times D all over, wait, D all over dx times Kx is equal to 4. Now you're going to get the derivative of your Kx. So if you're going to get the derivative of your Kx here, since it is in second derivative or second order derivative, so you will have 0 here. Because the first derivative of your Kx is K. And getting the derivative of your K for your second derivative is 0. So we will have 3 times 0 minus 6 times here, going to get the derivative of Kx. So getting the derivative of your Kx will give you K. All right, then is equal to 4. So this would be 0 minus 6k is equal to 4. And we will have negative 6k on your left side, and on your right side we have 4. Then divide both sides by negative 6. I'm just gonna bring it down. Then your k is, your k is equal to negative 2/3. Since your k is equal to negative 2/3, therefore, your v is equal to negative 2/3 of x, or negative 2/3 times x. That is your v. Now let's let's compile everything. So your y is equal to, u plus v. So your u here is a plus b times e raised to 2x. And then your v, we have negative 2/3 of x. So see, this is your general solution. See, this is once again your general solution. Okay? But what if I'm gonna give you some given variables and you're going to find a particular solution? So what if your x is equal to 0, your y is equal to 2, and dy all over dx is equal to 4. What if? Okay. So we have a particular variables for x, y, and your dy all over dx. So how will you get your particular solution? Okay. So this is just a bonus. So if you want to stop watching, then go. Don't. You can just leave this video. But if you want to listen more, then there's no problem. All right. So once again, copy the general solution. Y is equal to a plus be raised to 2x, wait, minus 2/3 times x. So let's substitute everything in this general solution. So your y is equal to 2, so that's 2, is equal to a plus b times e raised to 2. Since your x is equal to 0, so this would be times 0 minus 2/3 times 0. So we will have 2 is equal to a plus b e raised to 0 plus 0. So we will have 2 is equal to a. So remember that remember that anything raised to 0 is equal to 1. So e raised to 0 is 1. Okay? So we will have 2 is equal to a plus b. And yeah, that's it. So find first. What do you want to find first? Your a or your b? So in here, I'm going to find, in this equation, I'm going to um, find my b. So I will have 2 minus a is equal to b. So here's the thing though. How can we find your a just to get your b? Okay. So how can we do that? We cannot just simply substitute 2a in here again because that would be very wrong. That's actually wrong. All right. So remember that we have dy all over dx. So we have another second equation, okay? Because this one, you have your y, that's your first equation. But remember that we have a given of dy all over dx. That would make us to have another equation. So this would be dy all over dx is equal to, let's get the derivative for this one, okay? So the derivative of your a is 0. Again, a is an arbitrary constant and act as a constant term. Therefore, it is just 0. Plus 2 times b e raised to 2x. That's a derivative of b times e raised to 2x. Minus the derivative of 2/3 x is just 2/3. Or 2/3, I mean. Okay? Now let's substitute. Your dy all over dx 4 is equal to 0 plus 2b times e raised to 2 times your x is equal to 0. So 2 times 0 minus 2/3. So let's simplify. We will have 4 is equal to 2b e raised to 0 minus 2/3. So remember, anything raised to 0 is equal to 1. So we will have 4 is equal to 2b times 1. Hold on. 2b times 1 minus 2/3. Okay, so we will have 4 is equal to 2b minus 2/3. Okay, so let's combine similar terms. Transpose 2/3 to the left side. We will have 4 plus 2/3 is equal to 2b. So if you're going to combine them, 4 plus 2/3, that would be 15 all over 3. Okay, is equal to 2b. So if you don't believe me, okay, 4 plus 2/3. Actually, this is quite basic. Why do I need to? But anyways, I'm just gonna proceed anyway. there are two methods on how would you make them into a whole fraction. So you can use butterfly technique, or you can just use this method, making a mixed fraction into a proper or improper fraction. Okay, that's how I basically used it often to make this one into a whole fraction. Okay, so basically 4 plus 2 third. So multiply 3 by 4. So 4 times 3, 12, right? If you're going to multiply them. Now, add 12 to the numerator. So again, 4 times 3, 12. Okay? Plus 2, 14. So I'm wrong. It is actually it is actually 14, not 15. Okay? So this is 14 all over 3. Okay, there you go. Sorry. It's 14 all over 3. That's it. Or you can use butterfly technique. So we have 4 plus 2 third, right? And here, since 4 is a whole number, therefore, they can have a denominator of 1. So anything, a whole number or whole term, as long as it is a whole number, okay, or whole part whatsoever, they have a denominator of 1. So butterfly technique, 4 times 3 will have 12. Then 2 times 1, we will have plus 2 all over 1 times 3, we will have 3. So we will have 14 all over 3. So that's how you do it. Okay. Sorry if I'm sorry if I was what's that? Sorry if I was rude. Okay, to say that it is basic because we're already in in different topic and this is not actually basic anymore. So sorry about that. So go on. So let's find your b. So we're going to divide both sides by 2. So we will have 14 all over 6 is equal to b. Okay. So in this case, okay, 14 all over 6, you're going to have 7 all over 3. Okay. Because if you simplify 14 all over 6, this would be 7 all over 3. Okay. So that is your b. All right. So since this is your b, then we can substitute it here. Right? We can substitute it here. So we have 2 minus a is equal to 7 all over 3. Okay. Now that we have this one, okay, 7 all over 3, we have a denominator of 3. We can cross multiply. We can multiply 3 to this expression. We will have 6 minus 3a is equal to 7. Now, transpose 6 to the left, we will have negative 3a is equal to 7 minus 6. So, hold on. There you go. So, negative 3a is equal to 7 minus 6 is 1. So, divide both sides by negative 3. We will have a is equal to negative 1 third. So, since you have your a and your b, therefore, your particular solution is y is equal to negative 1 third plus 7 over 3 times e raised to 2x minus 2 third x. That's it. Okay? That's basically it. Okay? So, yeah, this is your particular solution. Okay? You can simplify this one actually. Hold on. You can simplify this one. You see the terms negative 1 third, positive 7 all over 3 times e raised to 2x, and negative 2 thirds. These three terms, are both divisible by 1/3. Okay? So we can simplify 1/3 here. Simplify 1/3. We can factor 1/3 in this expression. So we will have y is equal to 1/3 times quantity -1 plus 7 e raised to 2x minus 2x. Okay? So you can arrange them from positive number until negative number. So we will have 7 times e raised to 2x minus 2/3 x. Oh, wait, sorry. Minus 2x, I mean, minus 1. Okay, so yeah, this could be also your particular solution because it's still correct. Or you can factor out -1/3 instead of 1/3. There's no problem. Okay? You can factor out -1/3 here. So we can just say y is equal to -1/3 times quantity 1 minus 7 times e raised to 2x plus 2x. Okay? So if you're going to arrange them, we will have y is equal to -1/3 times quantity 7e raised to sorry, -7e raised to 2x plus 2x plus 1. You can have that as your particular solution, but if you want to put only positive numbers at first, then we can have y is equal to -1/3 times 2x plus 1 minus 7e raised to x, raised to 2x. So yeah, basically these are just possibilities, okay? So it's up to you whether you like the first choice of your answer, second choice of your answer, third choice, or fourth choice. Because again, four of them are all correct. So yeah, this sums up on how would you find the solution for your second order non-homogeneous differential equation wherein your function f of x is a constant function.